eliminate, well, first of all, here's the basic idea of what we did Friday. We had 3 equations with 3 variables. We picked 2 of those equations to eliminate one of the variables. Then we pick a different 2, and we eliminate that exact same variable. Then what you have is this. 2 equations that have only 2 variables in it. And you solve that either with substitution or elimination. It gets you down to 1 variable. And then you substitute it back in twice to get all 3. You can, on this problem actually, you can choose X, Y, or Z. And any of them are easy to eliminate because there's at least one equation where they each have just a 1 in front. And that makes for easy math. However, I've worked this problem in 3 different class periods today, and I highly recommend you don't choose Z because it makes really ugly math numbers. That's not, it's okay, it's manageable. But I'm about to give you an option, and if you say Z, I'm not choosing. Are you ready? Which variable would you like to eliminate, X, Y, or Z? Y. Okay, very good. It was just a fake choice. I wasn't really good. So we chose Y. Here's what we're going to do. You pick 2 equations to eliminate Y, and I'm going to do this. Because the second row has the Y without the coefficient, I'm going to use that both times because it'll be easy. So I'm going to choose this one and this one. That's one combination. And then I'll choose this one and this one. Now on Friday, the lesson, or the examples we did, I think we used the same combination of rows both times. I think we did 1 and 2, and then 2 and 3. Okay, that's just a coincidence. You don't have to. Oh, that's what I did here. That's just coincidence. You don't have to. I think earlier when I solved for X, when I eliminated X, I chose rows 1 and 3 and 1 and 2. So don't think you have to do the exact same method. Doing the star equations first. So I'm eliminating Y, which means I would really, 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 really like for 2 to be right here. Because when I go add them, the Y's will cancel out. In order to get a 2 there, I can't just multiply the Y by 2. It has to be the entire row. And I showed you this notation on Friday. I said, I'm going to take row 1, and I wrote it like this, plus 2 times row 2. Now, I'm not going to require that you use that notation or that you mark stuff with symbols, but here's the benefit of that. When you get lost in your problem, especially if you're not like a real linear worker, if you write all over your paper, marking them with symbols will help keep your math straight. And if you do something like this, when I come to your desk, I don't have to start cold on your problem, trying to figure out what you did, because there's a bunch of different ways to do these problems. It takes me a minute. I have to go through every with a cone to sort of figure out all of your math. So it's helpful for these. I'm going to do it every time, especially if you go look at my notes or homework sheet. It'll help you know what I did. So this is what I'm doing. Row 1 doesn't change. Row 2 gets everything multiplied by 2. Every little thing, even the constant on the right-hand side. A lot of students forget to do that. So it's 6x minus 2y plus 12z equals negative 14. Now, on your quiz, when I was grading it, I saw a lot of people doing this. They might have done all that correct. They canceled out their variable, but then they would just take one of these equations and write it down exactly how it already was. They weren't actually adding all the other parts. That's what's canceling the variable out, is because you're adding the 2 equations. So you have to actually do x plus 6x and negative 4z plus the 12z. And then that equals negative 7. And once you get that, you just let it hang out there. Just let it sip a little glass of sweet tea with lemon right there, and don't do anything with it for a while. You're going to take the other 2 equations and eliminate the same variable. So that will look like this. That was the star equations. Now I'm going to do these two heart equations. And we're trying to get rid of y. I'm looking at these two. They don't cancel out if I add them right now. I would really, really like a what to be right here. For these to cancel. 3. So because I want it to be 3, I'm just going to multiply everything there by 3. I'm going to do 3 times row 2 and add it to row 3. So 3 times row 2 is 9x minus 3y plus 18z equals negative 21. And this is row 3. And I know that me like talking calmly up here, writing a long problem, can mean that you're zoning out right now. Someone could be checking my math while I work out. Because have you noticed one little thing messes up all the rest of your work? It's quite obnoxious. So the y's cancel, giving me 11x plus 17z equals negative. Oh, this is obnoxious. Who said y? Okay, so now we have these two equations. I don't think I've done y yet. It's an x. X is the best. I can make it x. Many clusters ago. So here is my system now. We have this two equations of two variables. At this point, you could do substitution. I'm going to do elimination. It doesn't matter if you choose x or z. I'm going to go with x because I feel like the math is easier. And in this case, you have to multiply each equation by something. And that's okay. That's the thing. And what I'm going to do, and they have the same sign right now. So one of the factors you multiply needs to be negative. So I'm going to multiply this one by negative 11. And this one by positive 7. Right? Because I'm canceling the x's. So this gives me negative 77x minus 88z equals positive 77. And then 77x plus 10 times 7 is 70 plus 49, 118 equals negative 77. So not only now do the x's cancel, but the constants have to cancel too. And negative 88, 118 is 12 is 31. 31z divided by 31, z equals 0. And that's a whole lot of work. I'm not even done. When you go to find your next variable, do not go all the way to the original problem. It won't do any good. If you took that 0 up here to one of these equations, the z would drop out, but you'd still be left with two variables, and you'd be stuck again. So stay here in the middle part of the problem where you have these two equations. Because there's only two variables there, and now that you know that z is 0, you can put it in either one and get x. Would you like this left one or this right one? Right? Okay. So using that right one up there, I'm plugging in 0 or z. So I've got 7x plus 8 times 0 equals negative 7. 8 times 0 is nothing. Gone. Divide by 7. X equals negative 1. And then now you take those two back to the original equation. It doesn't matter which one you do. You want equation 1, 2, or 3? 1. Okay. So looking at equation 1, x, which is negative 1, plus 2 times y, which we don't know, minus 4 times z, which is 0. We'll try to say z is 0 all day, equals 7. This is gone. Add 1 to both sides. 2y equals 8. Y equals 4. please don't forget, yeah, as an ordered pair. Please don't make your answers like this. You want to write it as an ordered triple, where x is -1, y is 4, z is 0. Who got the answer right all by themselves? Very good. Those of you who are raising your hands, which of you eliminated x first? Who of you eliminated y first? And who eliminated z? You see, it doesn't matter which one. As long as your math is good, you'll get the same answer. Any questions I can answer for you about the problem? All right, so spend a minute getting your notes and homework out if you haven't already from last Wednesday. It's day 3. It's the word problems, where we have the jeweler who had the gold alloy and was making a custom